So we proceed with the final section, which is section 3, the stability for the discrete signal. Okay, it's similar with the stability in Laplace. Okay, so I will do comparison first in Laplace and also in discrete or in Z transform. In Laplace, the region of the stability left hand side. This is real, this is imaginary, this is 0. So as long as the pole, we talk about the pole, poles on left hand side of the S-plane. As long as the pole on the left hand side, the system is stable. However, for the discrete, you also have the region of the stability for the poles. The region of the stability of the poles, we call this is unity circle. Unity circle, where the radius is 1, this is also -1, this is j, this is -j. So it means that the radius is 1, as long as the poles inside the unity circle, the system stable. Okay, I give you example. We do comparison. Comparison. In order to determine the stability, we always use the transfer function. So let's say the transfer function Hs for a system Ys over Xs is 3 over S plus 2 S plus 5. We look at the poles location. The poles location, we look at the denominator part. The denominator part we call as a characteristic equation. Okay, the poles as -2 and as -5. So we try to put it up -2, -5. So you can see that the -2 and -5 inside the stable region. So we can say that system is stable. Okay. Now we look at this one for the discrete Z transform. Let's say the transfer function of Hz equal to Yz over Rz. Okay, there are two poles here. The first pole is the poles Z 0.5 and Z -0.7. And then we try to plug in here 0.5 positive 0.5, Z equal to -0.7 should be here. So you can see that the poles location inside the unity circle. So it means that the system is stable. Stable. Okay. So we go back here again. We go to the second example. We do the comparison. So this is cancel. So we know none here. Where is my blue marker? Remember, this is the region of stable. We cancel this one again. This is the region of stable. And then after that, let's say the transfer function for the second example is Hs equal to Ys over Rs equal to 7 divided by S plus 2, S plus 6, S plus 10, S minus 1. And then this one, hz yz divided by rz. Okay, 7 z minus 0.2 z minus 0.8 z plus 1.2, something like that. Sorry, z minus 1.2. So in here we find the poles again. Poles as at -2, -6, -10 and 1. So we try to plug in -2 here, -6 here, -10 here, 1. So you can see that these are unstable. Okay. Similar with this one, we find the poles. Z at 0.2, this one give you 0.8, this one give you 1.2. Is it? And then we just plug in. 0.2 should be here. 0.8, 1.2. So since this is outside of the unity circle, so unstable, since there is a pole outside the unity circle. Okay, so this is how you determine the stability of the discrete system. Okay, and also I do comparison how you find the stability for the Laplace equation, transfer function. I think that's all that you needed for the discrete system. So let's say if I think you need another information related, if I think you need to have other information, I will let you know. So far everything is good. Okay, so hopefully you study well for this thing. So hopefully this video will help you in order to score for your final exam, inshallah. Okay, thank you so much for your attention.